So you said you had some questions notationally mostly?
Well, really, for the first problem he did, and I mean, these are in his notes.
Yeah.
When we first started with the like finite automaton, he gave this problem of how to use it to tell if the word is the binary representation of a number divisible by 3.
Yep. Okay.
And so he sets up this table and then like the diagram too, and he uses this notation for NW.
Okay.
And I don't know what he means by NW, and he also differentiates between NW and then NW0 and 1, and I'm not sure the difference.
Yeah, no, that's fine. So what did you say your background was? I can keep it in mind.
I'm a maths major.
Yeah. Okay. Then I don't think you'll have any problem with this. It's mostly just, like you said, the representation. So N is... So a binary string can be thought of as a number in base 2, right?
Yeah.
And you're familiar with bases other than 10. So he's using NW to mean... So notice that like, the mod notation he's using is... We generally think of as being defined in the usual base we use, base 10, right? So he's using N as a function to convert the number from binary to base 10. That's all N is.
Okay.
Right?
Okay.
So what does it say exactly in his thing? It says, let NW denote the integer that W represents in binary. So NW equals number in base 10 that W equals in base 2. Right?
Okay.
Does that make sense? So if I put... I should write bigger for the sake of it. If I put like... What number is this? So
is it 4?
Yeah.
4? Okay.
Let's just do a quick review of bases, just so it goes faster for you in the future. So like I think you understand it, but it's depending on how you're thinking of bases right now, this might make it easier. So when we think of a number in base 10, where'd that eraser go? Oh, it's over there. You mind passing it to me? Thanks. Okay. I think this is, I'll write over here. How much space do I have? Mostly I have over here space. You know what? I think I'll move this down.
I can move too if that helps.
No, it's okay. I think it's fine. I just need to get this wire. where the sound goes in. Oh well.
Oh. That's great.
Damn, I wonder how much I missed. Oh well. The most important thing is that you guys get it.
Yeah.
I mean, this is like a secondary thing that's
Right.
nice, but yeah.
But he puts then the transition functions into a table, and I'm kind of.
You can draw out that table if it helps you.
Okay.
So
Like
the
how?
table is. So your alphabet is ABC. Your states are these. Okay. So the left-hand side of it. Let's do it with binary to make it a little simpler at first.
Yeah, that's fine. I mean, you can use this
And actually, I can
example.
use the. Yeah, I could use this example, can't I? Yeah, let's just do that. Good idea. So where can I keep writing? I can write here. So there's Q0, Q1, Q2, and then I prefer to have this. There's 0 and there's 1. What state does 0 take you to from Q0?
Back to Q1. Q0.
Yep.
Okay.
And then 1 takes you to Q. Oh, these are labeled really weird. One sec. Because they're still labeled as they were when the DFA was much bigger. Sorry about that. Okay, let's switch it to something more intuitive. So this goes to Q1, right?
So if you are at Q0, you have a 1.
Yes.
Then you're saying what it takes you to.
That's exactly it. That's all it is.
Okay.
I can fill out the rest really quick, but you get, I think you understand.
Yeah.
That's it. I personally find the picture more telling. If I'm trying to just decipher what the states do, if that makes sense. I don't know. I'm just a visual person, so. But certainly as you get more states and more symbols, this is a more practical representation
Right.
of it. Yeah.
Okay. Then for ones where you are using like letters like A, B, C or whatever, you said the best way to start for binary or whatever is using the empty string. Is that still the best way if you're using letters?
Sorry, could you repeat that?
So if
spaced out for a
you're instead of like this example is over 0 and 1. If it's over A and B, should you still start with the? I guess you would still start with the empty string.
Yes.
As a starting point. Okay.
Definitely. The empty string is always a possibility, right? Like if I give you, you really can think of the reason that these are called an alphabet and a word, or like you can think of a string as a word. In your language, and like the language, it all like makes sense when you kind of convert it back to English, right?
Okay.
Like that's a word in English, but like is not a word. It's not in the language, right? It's a word made up of symbols from the alphabet, but it is not in the language.
Right.
So that's like
Okay.
the intuitive conversion, like that's why these terms are being used the way they are. I think I initially found the vocabulary a little strange because I was still thinking of them as like base 2 numbers.
Yeah.
But yeah, sorry, did you have any questions in particular?
No, I was just gonna come and see what you guys.
Sure.
About.
Yeah, no, I do that for
Yeah.
most of my classes too.
Well, I've got another one if you don't.
By all means.
For problem 2 on the problem set, I guess, I was trying to use induction on like what he's been doing a lot in class is induction on the length of like y to prove it, but which is I guess so then the base case is with the empty string, but then I was kind of getting caught up on how you can like so I don't know how much I can ask based like what I've done so far.
Sure.
Answer. But so I was thinking that like So if I'm saying that y is the empty string.
Give me 1 second just to read the problem statement.
Oh yeah, sorry.
No, it's fine. I like to look at the problems ahead of time. I just didn't see where they were this time. Okay. Thought he might have given them in class or something. Anyways, recursive. Extended transition function. Oh, it's when you allow words as the transition. Okay, fine. That's convenient. Proof it for all. Right. Okay. That makes sense. So yeah, let me look at your.
Yeah. So just like for the. So we're saying that y is epsilon then. So then, but then I just don't know if you've gotten rid of it. How do you just add it back on? Like
So
like
this is just your base case, right? This is not the inductive stuff.
yeah.
So this part is all correct. This step seems to be the same thing twice.
I just read that
Yeah. And then let's see. Okay, and now can you compare it to this side? How do you show their equivalence? So here you have.
Like he's been.
Why is there a?
He's been like rewriting them as like. In parts, I just wasn't sure where to go with it.
So I mean, I guess the way I find the most intuitive to do this part is, what happens if y is epsilon on this side? Forget this w business.
Yeah.
Okay, and let's just see. We've got this, and now, how is this?
Because I was trying to use that definition. Oh yeah, the definition I guess he says where it can, because that's in a similar format to
right.
that.
That's you're going to need that.
But that doesn't have the hats on it. Not
sure.
all of them, which I guess is what you're.
But if there's a. Certainly, if there are no symbols, then the hat notation will actually reduce to this. But so, what identities do you have about the hat notation? It's in here, or
yeah, it's just I just wrote these two down. For A is just a symbol and X is the actual word. It's these two.
Q, A, and X, where A is the first symbol. Is that right?
Yeah.
And X is the remainder of W. Is the rest of the string? So you're saying W equals AX.
Yeah.
Okay. And where A is a single symbol. It's the first symbol. Okay. So here, you're saying sort of the opposite. Yes, the reverse. And what you need right now is the reverse. Because now you're right. You can say this is equal to this. But I think what you should have done is not remove the
epsilon.
Because you're gonna say that. I mean, it doesn't really matter if you remove the epsilon or not. W is going to be epsilon though, right? W is equal to epsilon. Then you do this, and it's just epsilon here. And you can say.
But that gets rid of the X then, because you still have to have an X there. Because you have the 2, the X, and the Y.
Sure, but you don't need to change the X into. Okay. No, because really, like here, W was like AX or XA, right?
Yeah.
Here, our W should be X epsilon. So basically equals X.
Why can you do that?
Oh, why not? I'm defining W, right?
Yeah, but if I'm defining Y to be epsilon.
So wait, Y is. So you're saying y is equal to epsilon.
Yeah.
And so you had xy here,
So
and now it equals epsilon. So
can
w is xy.
W.
But you want a single symbol here, you're saying? Oh, I see, because this is a single.
Words.
Give me one moment. Let me look at the.
Yeah.
Are they in the lecture notes online? These.
Yeah. It just
things?
takes you right to it.
Yeah. I haven't seen anyone use. They didn't use this notation last year. I don't think for anything.
I think he's referencing 10 2.10 is the definition.
2.10.
Yeah, it's farther down. It's yeah there.
Okay, so you're saying this for A, which is a single letter in the alphabet, right? And the alphabet doesn't include epsilon. So I see your concern, but this is important.
The first one?
Yeah, this thing is extremely important, right? Because when you have this with where this is epsilon, I think you're going about this in the wrong way. The use of this part is not what you want to do.
Okay.
You're trying to use this second condition, which requires you to have a single variable in the lead or at the end.
Yeah.
But what you really want to use is this identity. That's what I was getting confused. I was like, I mean, either you have to be able to put nothing here, or you need a separate identity for epsilon, which, oh, there it is. I see.
Yeah.
I missed it. Does that make sense?
Yeah.
So now you can do it on both sides, and they should be able to come to equality, right? Does that make sense? So here, you had q of xy, and then it easily becomes q of x, right?
Yeah.
Here, let's just start from the same place, right? Where we have, what are we starting with in the problem statement? I want,
Yeah, you just.
yep, so, I'm going to erase this quick. Why did I write that? Okay. So, why can we get this equals, so our desired conclusion is this, and I posit that I can actually use just the rule about epsilon to get this equality. So what's equal to epsilon right now?
Y is.
Right? Can I use either of the rules he gave us to simplify this?
Yeah, so if there's anything in that component of the delta hat, then it just becomes the first component.
Right.
Which
exactly.
is just that side.
Exactly.
But then.
Which means they're equal, right? Because you got this side starting from.
Oh, I see. Okay.
So I think the way to think about this part was to converge to the same simplification. Does that make sense?
Yeah.
Not to do any fancy tricks with W.
Okay. Cool.
You see which part we're talking about? Yeah.
Okay.
Yeah, the second set of rules of those like rules about taking the last symbol in the alphabet or the first one, it's not going to help you with epsilons.
Okay.
You just need to rely on this rule.
Okay.
Was that helpful?
Yeah.
And then the inductive step was okay. Yeah, you've probably done a fair bit of induction
More of
as
that,
a
yeah.
math major, so.
Okay. Oh, what does he mean by an inductive definition, though? I think I got a definition, but I don't know. Is there like a technical for an inductive
Just clearly state what you're
definition?
performing induction on for this problem. Where does he say inductive definition?
In one.
Give an inductive definition for the complement of a word. So you want to give a. Do you mind if I see what you wrote and I can kind of just confirm?
So, if W is a string, then I'm rewriting W as XA, where X is a word of one shorter length, and that's the last symbol. So then, W the complement, I guess is what it is.
Yeah.
Is and then there's the opposite value.
Yeah, that's an inductive definition.
Okay.
Did you get that part, the 1A, for like coming up with an inductive definition?
Yes, I think so.
Right.
Okay.
I mean, you really just want to, assuming you have a definition for something of one shorter length, tell me what to do with the last symbol, right? Like you just pull off the last symbol, the rest is going to be of one shorter length, and then you want to complement this last symbol, and that will, now you've successfully complemented a string of length n from a string of length n minus 1 in a single symbol, right? Yeah.
Right.
Okay.
Yeah, I don't know if I've seen the term inductive definition anywhere, but intuitively what you wrote is definitely what he meant.
Cool.
Cool.
Yeah, that's another weird thing about this being like a CS class than math, because the standard symbolism is just very different. Like when he's using complement and he's using like W bar,
Yep.
if you're using bar in math, that means the closure.
Right.
Definitely not the complement.
Yeah. It's it's entirely different nomenclature, and I studied logic as an undergrad, and that also can have very different nomenclature, and it's just a mess.
Yeah.
The worst thing I've ever seen in a textbook, though, was definitely when a guy tried to stop using parentheses, and
what?
he used dot notation, which is basically you'd put dots between things, and basically whenever you had an operator, you would put dots to the bottom left as like a subscript to either the left or right of it. Actually, I think it was usually as like in the subscript spot, you put a number of dots, and then you basically prioritized like you had to like match dots and prioritize like in various directions depending on number of dots. It was the worst thing I've ever seen.
What's the point of that?
There was no point. I think this apparently, like, some people thought this was a good idea a long time ago, and then people quickly realized they were very, very wrong.
Yeah.
No, exactly.
That sounds horrible.
Yeah.
It was pretty horrible. I think I read, like, the whole thing in a couple days, and I was, like, scarred after that textbook. So, if you still have any, the PSATs due when? Wednesday. So there's another office hour tomorrow if you have any further questions with Jafar. I think it's, noon to 1 in the same room. In general, right now I'm covering his office hours. He'll be at my office hours tomorrow because he had a conflict with his usual ones. Generally, he'll be on Mondays and I'll be on Tuesdays.
Okay.
And then I'm sure like there's Piazza for this class, I think. And you can always shoot the TAs or the professor emails if you have any additional questions. Cool. Thanks for coming, guys.
Thank you.
No problem.
Oh, what is the YouTube account name that you?
I'll link it up, yeah.
Oh, okay, cool.
Yep, I post my video posting notices like on Piazza. And
Okay.
then, yeah.